Assalamualaikum warahmatullahi wabarakatuh, especially for our lecturer, Madam Rosita binti Muhammad Mokhtar. So today my group will present based on problem-based task. So before that, let me introduce myself. My name is Muhammad Hariz bin ZAHRULLAIL and my message number is 01DDT21F1029. So today we are going to present about routing protocol that we have configured on this topology, and we also have do some observation on HSRP that stand for Host Standby Router Protocol. So without waste any time, the basic configuration, which is IPv6 that have on this information already configured to each port and included device such as a DNS server and web server. And then we have also configure a stateful DHCP-V6 for the server and client, which is on RTB, RTC, and RTD. And then we also configure a static host route for web server on RTA. And then the default static route on ISP. And then we have to test the performance and application by using the ping command to access www.berjaya.com. So for my part, I will take over for this connection or network, which is for RTB. So to see the configuration or routing protocol that have been concluded on this configuration, we have jumped into terminal, and then we are going to enter the privilege exec mode by using this command. And then we show the config to see the configuration that I have. So for this, I have configured this RTB as a IPv6 stateful as a server also. So for this line, then conclude for address traffic also, and then we can see the DNS server and domain name. And then for next is we also configure the IPv6 route that included on this network. So for remote network, they conclude which is DIT1, FIT3, DIT3, FIT1, FIT4, FIT6, DIT5, DIT4, DIT1, FIT3, DIT3, FIT1, FIT4, FIT6, DIT5, and last but not least we have DIT4. So for this IPv6 static route, we use a fully specified. So we have to include a remote network, which is an easy interface and also link local address. So for this topology, we assume that a remote network that I have assigned from this network, DIT1, and for this network, FIT1, this network, DIT5, FIT3, FIT4, DIT4, DIT3, and DIT6. So we configure from this way and this way. So it will be going to balancing, which is the path can be used for the two-way of the connections. So to test the DHCP server that work properly, we have to test and verify from the PCB1, which is end device or client, and then we try to go to the static, and then we request back the IPv6 to server. So as you can see here, IPv6 request is successful on this PCB1. So let's try this one on this PCB2. Alright, as you can see here, the IPv6 is request successful. So now we are going to testing from this network, which is we have to pick PCB1 and PCB2 to get access to the server and web server. So for this testing, I will pick from PCB2 to verify this connection. So we are going to command from, and then we have to ping on the DNS server first, which is DIT1 $2, then we can enter. So as you can see here, this our packet are being received and replied by DNS server. So the ping is successful. How about DNS server? How about for web server? Now we are going to test. So we have to put DIT5 $2, which is IP for web server. So we have tried to ping. So as you can see, all of the packet that have been reached to web server successfully. And then for the path that has been determined for this router, we are going to trace it out for web server. So for trace it for this path determination that has been determined by this router, this is a way that has been used to reach the destination that start from the D2 1 and end up with D5 2, which is web server. So now we are going to see an observation on SSRP. Typically, if you see on this topology, we can verify that RTC is a standby router, while meanwhile for the RTD and the RTB is an active router. So to verify that, I will go to the RTB and dive a look in this terminal. So we are going to find out by enter previous user mode, show run. So to detect configuration or detect the configuration SSRP on this router, we have to verify that the connection that has been used as SSRP routers get connect. So we can see the Gigabyte Ethernet 00 is a connection to this active router. So we have to find Ethernet Gigabyte 00. And this, if you can see Ethernet Gigabyte 00, the standby version 2 standby 1 preamp has been configured on this interface. So we can verify that the SSRP has been configured by standby 1, which is referred to the group 1. So to verify the testing part, I will remove or shut down this interface Gigabyte 00. Alright, now we are trying to access the web server via web server. Have to wait for a while. Then we put www.dzulshahrir.com. Alright, once the display has been displayed like this, its sign of access or the to web server is successful. So now we are going to test by trace it. So we are going to trace it to this web server IP, and then we have see how it's going. So as you can see here, the trace route is inconsistency, but the summary that we get from this trace route that the trace route has been completed, and then it says reach to the web server, which is D500. So I think that's all for me. Now I will pass to my friend to continue this presentation. Thank you.
Thank you, Hariz. Assalamualaikum, Ms. Rosita. My name is MOHAMED MUZAMMIL bin MOHAMED IRUSATH. My matric number is 01DDT21F1063. So what I will be doing today is, I'll be demonstrating the HSRP that is pre-configured in the router RTC. So before we jump into the HSRP demonstration, let me explain what I configured in the RTC router. So first of all, let's start with DHCP. So let me explain to you which remote network is for router RTC. So for router RTC, there is 5 remote network, which is DIT1, FIT1, DIT5, FIT2, FIT4. So that is the remote network. So the other networks are direct network, such as example FIT3, FIT5, FIT6, DIT3, DIT2, and the last one is DIT4. Okay. Now I'm going to show you configure DHCP v6 server endpoint. Okay. So let's go into the RTC router and click the command show run. Okay. So this is what I configured for server. DHCPv6 server and pool. So I've concluded pool LAN C, pool LAN B, and pool LAN D. Okay, now I'm going to verify that my client, which is PCC1 and PCC2, have successfully obtained their IPv6 automatically. Alright, so I'm going to click on static and automatic again. So as you can see here, IPv6 request successful. And the next client, which is PCC2, we click static and then we click automatic again. As you can see here, there is IPv6 request successful. So we can say that the DHCPv6 server command configuration is correct because the client is getting all the IPv6 assigned automatically. So now I'm going to explain about the HSRP. Okay, so before that, let me explain to you what is HSRP. So as an example, there is two router, router B and router C. Alright, router B is an active router and router C is a standby router. Okay, so for the client to go to the web server, in the default value, it will use router B because it is an active router. Okay, so in some case, if router B is shut down or router B's connection is removed, so the clients will use RTC, which is the standby router, to go to the web server. Okay, now I'm going to ping one of the species, which is RTC client, to web server and DNS server to show that it can be pinged successfully. Okay, now let's go to terminal. Sorry, command prompt. Reset. Sorry, ping 2001 db8 dib52, which is web server network, right? So as we can see here, we have successfully pinged to web server because there are 4 replies over here. Now we want to ping to DNS server. Okay, also if the RTC client, which is PCC1, if they ping to DNS server, it is also successful. Alright, so now I'm going to show why, how do I say RTC is a standby router. Right, so let's go into RTC. Okay, and let's click RTB as a comparison for RTC. Okay, so why do I say RTB and RTD is an active router and router in the middle, which is RTC, is a standby router? Okay, so for example, if we can see preamp, right? If we can see preamp command over here, it means this command can be only done to active router. We want to set it as an active router, so we need to enter preamp command. Alright, so if we see here, there is no preamp command. There is no preamp command, and it's only standby version 2. Which, if we did not conclude preamp priority, that means that specific router is a standby router. Okay. Now I'm going to trace it to web server using these clients. Okay. Now we use PCC2. Command prompt. Trace it. Okay, so as we can see here, the trace is successfully completed, where the client can trace to the web server. Right, so now we need to see which pathway does the client PCC2 uses to access to web server. Okay, the first pathway is it uses DID31. Okay, it uses DID31, which is RTC. As you can see here, there is DID31 over here, and then it uses FIT21. FIT21 is, I guess it is here. Yes, correct. Which we can see here in serial 000, there is FIT21. And then it goes to DID31 again, and then it jumps to FIT1 over here. And it successfully accessed the web server. Okay. Now I'm going to show on this PC over here to prove that it uses active router and as a standby router. Alright. So let's take this. Command prompt. Reset. Okay, so we can see here it uses DID21 and then DID22 and then FIT11 and FIT22. Okay, so let's see where is DID21. So in RTB, okay, as you can see here, DID00 is DID21 and it goes to DID22. I guess it is here. yes, we can see here that in serial 00, we can see that DIT22 and fit11. Okay, fit11, it goes over here, and fit22 again. That means it uses the, let me find where is fit22. So I guess it is here. Yes, fit22 is over here, and fit11 should be over here. Yes, over here. I think so. It's on ISP. Yeah, fit1. Okay, so it uses this pathway where it goes RTB, RTC, RTA, and ISP. Okay, supposedly we can see, we can already see that in RTB there is preamp command, so it should use here. Okay, now let's test it out where we delete gigabit Ethernet 00 cable and we trace again. Let me trace it again. Let me trace it again. Trace it again. Okay, so let us take this pathway where it goes to DIT22, which is here, and RTC, and it goes fit32, which is here in RTA, and fit11 over here, and it reaches the web server successfully. Okay, so why do we use RTC pathway is because it doesn't have the connection to RTB. Alright, so it needs to use RTC, which is the standby router, to go here. Okay, let's test one more thing out where we delete this connection over here and we test, can it reach the web server? Alright, so let's test it out. Okay, there is some results. Okay, there is some results also. Let's test it out again. Okay, so I think so. This is one of the best that we can see. So it does use fit21, which is here over here. It uses RTB. It does use fit21. If we remove the gig 01 over here, it also uses gig 00 over here. That means it's not not working, but it is misconfigured where it does not include priority or something, right? So, and then you can see that fit1, that means it goes over here, the ISP over here, alright? So I guess that is all for my part. The next part will be continued by our groupmate ZULSHAHRIL. Thank you, Miss.
Assalamualaikum and salam sejahtera. My name is Muhammad DZULSHAHRIL bin DZULKHAIRI. My number matrix is 01DDT21F1023. So today I'm going to continue presentation for my team. So what we have to do on this PBT is configure the stateful DHCP v4 AV6. So first we do out the server. So here for my team I will show the configuration on RTD. So this is how we stateful the ICP v6 server. So first we have to enter the pool name, which pool landy. So next we have to configure the address prefix with DIT4. So next we have to configure DNS server, the DNS server, the IP, and then the domain name www.berjaya.com. So here the domain name for web server. So for stateful DHCP v6 client, here we have configured on interface gigabit internet 00. So standby version 2 and standby 2 preamp. So this means gigabit 00 is the interface for standby, which if this one interface doesn't work, so this standby can be used for send the packet. So next, I'm going to show you the configuration for static route. So here is the configuration that all the IP that doesn't connected, we call it remote network. So there is 10 remote network that they turn 8 remote network that doesn't connected to RTD. So here we use fully specific, which we have to use easy interface and next hop. So for the next hop we use local. So what is the reason why we do configure static route? Because it can be sent to the other router, so the packet can know the network address where to send. It can choose be the best path. So next, I'm gonna show you how it works. So first, I'm gonna show you the IP that automatic they got. So here we can see the network DID4. Here DID4. So when we get when the PC get their IP, so we can ping to web server, and we ping to the web server after we configure static route and others. Let's see. Here, ping web server. Here you go. Can be ping. Oh, let's see what way they go. So here we can see which pass the packet sent. So first they followed it for one here, and then it goes to it for two. Wait, sometimes it doesn't show you the best pass. So further we go to here, and then feed one here, and then lastly the packet arrive to the web server. So next, let's try we remove one of the interface. So here we see the packet sometimes can be loose because the interface we have shut down. Sometimes it can be wrong. So let's try web browser. So here it can be web, but the tracer sometimes can be good. So let's see if I delete the another interface. Sometimes That's it. Let's try to web browser. Yeah, you can web the server. Let's link the interface back. Let's see if we can ping to the DNS server. Let's see if the interface both connected, but does it can web the server? So it does can, because we do the ICP stateful server. Here we can see the name. That is all for me and for our team. Thank you for watching.